Hello, algebra students. Mr. Lawrence here, and we're going to do some more mixture problems. These are a little bit different. They're chemistry problems, but they're very much like the coin problems we did, just a slight little twist on them, and I'll show you that. So let's see the first problem here. A mad scientist is trying to make 200 milliliters of a solution that is 35% acid. So we want it to be 35% acid. I assume the other 65% is water, okay? That would be pretty acidic, by the way. I'm not sure what type of acid we're talking about, but 35% acid would be kind of dangerous. It would hurt your skin. All right. He has only 2 bottles of acid. One bottle, which is 40% acid, and bottle 2, which is 15% acid. Now, what he hopes is he's going to take a little from the first bottle and a little from the second bottle and mix them together so that the new solution ends up being 35% acid. Okay? Now, you can't really guess and check when you're doing chemistry. You need to be able to do the calculations correctly. Well, our job is to figure out how many milliliters should he use from each bottle to create the desired mixture. This is just like the coin problems with one small twist. So I'm going to get my table out here, and because if I can fill my table out, then I can see my linear equations. And so, let's see, I think I might have too many columns here. That's okay, I'll scratch some out for a second. Yeah, bottle 1, bottle 2 total. Yeah, I got too many columns here. So let me get rid of this. I got a little column happy there. Hold on, group, ungroup. And let me just get rid of that guy. And then I can maybe spread these ones out a little bit more. There we go. That looks a little bit better. All right, so what 2 variables are we talking about? Well, we're talking about the 2 bottles of acid. So bottle 1 and then bottle number 2, right? And then here's going to be our total. And then we're talking about milliliters. So how many milliliters? And then the percent of acid was mentioned. And then this one here is the milliliters of acid. Okay, and this is really easy to get, although at first it's kind of weird. But if you think of what Megan Ferrari said Tuesday morning about the coins, this is going to be really easy, very much like the coins. Okay, how many bottles is he going to use from, how many milliliters is he going to use from bottle 1? Well, Sean Tarbuck doesn't know, right? Remember that, he didn't know, and so he said, let's use a variable. Excellent. How many milliliters is he going to use from bottle 2? Well, he doesn't know, so we're going to put Y. Now, I'm not using B1 and B2 because it gets a little confusing, so I'll use X and Y. All right, now how many total milliliters does he need? Well, he's trying to make 200 total milliliters. Okay. Now, what's the percentage of acid for the 2 bottles? Well, bottle 1 is 40% acid, right? Okay, and I'm going to write that as a decimal. Okay, I'm not writing as a percent, I'm writing as a decimal. And the second bottle is 15% acid. And now remember in the other problems, we didn't use this box. We're going to use it here because the total mixture needs to be 35% acid. So, by the way, I have one equation here, right? X plus Y equals 200. X plus Y equals 200. Okay, the second, pardon me, bumped the microphone there. Hope I didn't give you a lot of feedback. Okay, the milliliters of acid. Well, remember when we had the nickels and we said, well, there were N nickels and nickels are worth 5 cents a piece. And then the money from the nickels we found by multiplying the 2 together, right? That's what we're going to do here. We're going to take the milliliters, total milliliters from bottle 1, the percentage of acid, and that'll tell us the milliliters that are actually acidic. Yeah, we just multiplied those together. So, for example, if we poured 100 milliliters from bottle 1 and it was 40% acid, then 40 of those 100 milliliters would be pure acid. If we could somehow separate the 2, we could separate them. You know, we didn't need a special machine to do that. I don't even know if it's possible. But if we could separate it, 100 milliliters, 40 milliliters of pure acid, and 60 milliliters of zero acid. Okay? All right, now we're not actually going to do that. I'm trying to just get the point across. So now to get the milliliters of acid from bottle 2, we'll take the percentage as a decimal, multiply it by the variable. And this is important here. We multiplied this by that to get that. We're going to multiply 0.35 by 200. Okay, so my second equation is going to be 0.40x plus 0.15y. And I'm not going to write this. I'm going to figure out what it is. Let me see. 10% of 200 would be 20. So 30%, 10% is 20. 30% would be 60, right? Now 5% would be half of 20, so that would be 10. And so 30 plus 5 is 70 milliliters right there. All right, I think I really want to do this by substitution. By the way, I love the conversation I heard Tuesday at the end of class. Nick and I think Derek Katrubes, the silly goose himself, were walking out of the room talking about how they were going to do elimination, but it seemed better to do it by substitution. Okay, not that I want you to do it by substitution, but that you're actually thinking about it. I think I'm going to solve for x because I would rather multiply by 40% than multiply by 15%. Excuse me. So x is going to equal 200 minus y. So I'm going to take 0.40 and put 200 minus y in there, and then plus a 0.15y. That'll equal 70. All right. So now I'm going to distribute here, right? And, you know, if 40% of 100 is 40, I wonder if 40% of 200 is only 20. Let's check it out. 10% of 200 is 20, right? Multiplying by 4 gets me 40%. Nope, I guess my logic was backward. I should have gone the other way. It should have been 80, right? But you see, always testing, always pushing, always looking for some new way to think about things. So 80 minus 0.40y plus 1500ths y equals 70. I'm going to subtract 80 from both sides, and at the same time, I'm going to combine like terms. So the right-hand side is going to become negative 10, and the left-hand side, I think, is going to be negative 2500ths y, right? 40 minus 15. Okay, now it's the same as a fourth. If I divide by negative 1/4 like this, that would tell me that y is going to equal 40. So, in other words, I'm going to need 40 milliliters from bottle 2. Then, getting the amount of milliliters from bottle 1 is easy because I'll just do x equals 200 minus 40, which of course is 160. So I'm going to present my answer like this. Needs 40 milliliters of the 15% acid solution, or bottle perhaps, and 160 milliliters of the, man, I'm really bad at typing those, aren't I? Okay, let's see here. Let's change that. The and the of the 40% acid solution. Okay. There we go. Now, your answer makes sense. He needs a lot more of the 40% solution. And to me, it makes perfect sense because if you think about like maybe a number line, okay, and on a number line, you have, let's see here, you know, the 15% would be like way over here, right? 15%. And 35% might be here, right? And 40%. If you put equal amounts from each bottle in, you're going to end up at the average of those two, which would be what, 27.5? That would be the average if you used 100 milliliters from here and 100 milliliters from here, you'd get 27.5%, right? Because they would average. But since we want our percentage to be so much closer to 40, I mean, it's only 5% away from 40, I need to use way more milliliters of this one. So I end up with 160 from this bottle and actually only 40 from that bottle. See, to me, it really makes sense because it's all skewed. Had I been looking for, say, I don't know, a 19% solution, well, 19 is closer to 15, so I would have used a lot more from here. Okay, let's try one more problem. All right, Harry Kaboom, the world's expert on creating nitroglycerin sticks, is planning a big surprise for everybody. He is hoping to create 500 grams of a substance that is 42% nitroglycerin. He has two jugs. The first, which is 40% nitroglycerin, and the second, which is 55% nitroglycerin. How many grams from each jug should he use to create the mixture? Now, my gut tells me that we're going to need a much larger number of the first jug, which is 40%, because 42 is closer to 40 than it is to 55. If this percentage that we're trying to create was smack in the middle, we'd need an equal amount. It'd be 250 grams and 250 grams. I'm going to guess that this one is going to be over 400 grams. Now, I don't know the answer. I'm actually going to do the algebra, but I'm just trying to show you how I think about this. All right, so again, I just copied that table, so let me make it a little bit smaller. Just get rid of this one here. Oops. There we go, get rid of that. And, okay. And we're gonna go Control G. Okay, so let's see here. All right, well, we've got two jugs, I think, in this case, right? And so there's jug 1, and then jug 2. This will be our total. And we need to take out some grams, right? How many grams from jug 1 do we need? Well, I don't know. How many jugs from gram 2? Beats me. And the total number of grams we need is 500. So our first equation is x plus y equals 500. All right. Now, we need to know the percentage of nitroglycerin. And I forget is it N2O2? I think it might be. I'll have to check with Mrs. Stanovic. I think it might be N2O2. I'm not sure. I better not put that in case it's wrong. It's nitroglycerin. Yeah, I'll have to check into that. Nitroglycerin, so I'll just abbreviate it. Nitroglycerin. Okay. The first jug is what, 40% nitroglycerin? And the second one is 55%. Oh, I shouldn't be doing percents. I should be doing decimals. Sorry about that. Yeah, I should be doing decimals. And so that'd be 0.4, 0.55, and then of course we need to make sure that's 42%. Okay, and then finally we need the grams of nitroglycerin, right? This one is how many grams are we getting from jug 1, and how many of those grams would actually be nitroglycerin? Well, we multiply the decimal by the variable, okay? And that'll be 0.42 times 500. Okay, so now I'm going to figure this out right away. Look, 10% of 500 is 50, right? Okay, and so therefore 40% would be, 4 times that would be 200, right? Now 1% would be like dividing by 10, and so therefore if I divide by 10, it'd be 5. Now to get 42%, I'm going to need 140 and 2 ones. Those are all percentages there, right? So watch how I do this. I so love to do this. I think it's so intelligent to just build it this way. I've got 200, and then 5, and then 5 again. That must be 210. This must be 210. And you're welcome to check that on the calculator. I guarantee it's right. I'll just check it for the sake of it, but 0.42 times, what is it, 500? Yeah, and there we go, 210. Absolutely, every single time. It's too easy. Math is so simple when you start to really think about what's happening in it. Okay, I didn't write down my second equation yet, which would be what? 40% x plus 55% y, and that'll equal 210. Again, I'm going to go substitution. I think I'm going to solve for x on this one because I can do 40% pretty easily. And so I'm going to get x is going to equal 500 minus y. So 0.40 times 500 minus y plus 0.55 y equals 210. All right, so we're going to do a little distribution. Let's see, 10% of that is 50, so 40% must be 200 minus 0.40y plus 0.55y. That'll equal 210. It's kind of ironic. I must have picked similar numbers here, but that's okay. I'm going to subtract 200 from each side. It won't always work out this similar, but that's okay. So we're going to get a negative 10 on the right-hand side, and I think that's going to be a negative. Oh, I must have a mistake somewhere. I must have a mistake. Because I'm going to get a positive error, which means I'm going to need negative. Let me go back and look here for a second. See if I can find my error. All right, x plus y is 500, or 42. Oh, silly me. There it is. Such a silly mistake. 210 minus 200 isn't negative 10, it's positive 10. In the last problem, it came out negative, and I think that's what I was hanging on to. All right, so I'm going to get 0.15y. And so I'm going to divide by 1500ths. Okay. Okay, and if I want, I can think about that. Like I can run to the calculator. I tell you, math is so much fun. I've got 10 over 1 times this. Well, that means 1500ths, doesn't it? Yeah, well, it's not going to come out pretty. Okay, I thought it was going to come out pretty. It's not going to. All right, I'll wimp out. I'll go to the calculator. No, I won't. Why would I want to do that? Silly Mr. Lawrence. Okay, let's do the division. Let's go long division. We'll go old school. 10 by 0.15. I'm going to multiply by 100, which means I multiply by 100. Okay, and 15 is going to go into 100, I think 6 times, right? So that'll be 90. And I'm going to subtract and get 100. And 15 is going to go into that 6 times, and that's going to be 90. And I think this is going to go on forever. So I'm betting you it's going to be about that when I round it to the hundredths place. Yeah, that sure looks right. Okay, 10 divided by 0.15. Oops. Yeah, I know this is right. I haven't done it yet, but second insert divided by, yeah, 66 2/3 essentially. So for a solution y, oh my goodness, there goes that airliner again. I'm going to need 66 2/3, right? And so to get the other one, I'm going to do x equals 500 minus 66 2/3. Well, 500 minus 66 will be what, 134? But then take away another 2/3 and I'm going to get 133 and 1/3, right? Yeah, there we go. So that should be our two answers. So we need 66 2/3 grams of, what percentage was it? 55%? 55% nitroglycerin, and oh, silly, look at that, it should be 433. Wow. Okay, I'm getting tired, I apologize. Then 433 1/3 grams of the 40% nitroglycerin. And remember, I was guessing that this one would end up being over 400. Sure enough. Okay, there we go. That's it for the lesson. Mr. Laurence signing off. Have a good night, everybody.